You're listening to DTFHN for June 15th, 2026. I'm your spec-compliant but poorly rendered host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who build the commons argue about who broke it. Today's a day for open standards winning fights. They were told they'd already lost. Let's get into it. There's a line buried in the ePub specification. Actually, let me back up. There's a tool called ePub check. It's the official validator. You run your ePub through it. It says valid, and you think you're done. Your file conforms to the spec. Ship it. Then you load it on a Kobo, and it renders wrong. The culprit is Adobe's RMSDK, the Reading Mobile Software Development Kit. This is the rendering engine that Kobo and a number of other e-readers have been built on top of for years. And here's the quiet, devastating detail. The spec says your file is correct, but the dominant rendering engine disagrees, and there is effectively nothing you can do about it. The spec is open, the renderer is closed. Guess which one wins on the device in your hands? Adobe's relationship with rendering standards is, let's call it, historically consistent. This is the company that had Flash, enormous market share, a technology that ran half the interactive web, and they let it rot rather than invest in quality assurance. They managed to unite every browser vendor against them, which is an achievement in organizational dysfunction that honestly deserves some kind of award. The pattern repeats. Adobe handed the ePub ecosystem a rendering engine, and then, from what people who've tried to build on it describe, made it essentially impossible to actually access or work with. One developer spent significant time trying to build e-reader software on RMSDK, and couldn't even get access to the SDK. The devil wouldn't return the call. The first principles question here is simple. What does an e-reader actually need to do? Parse a well-defined document format and put text on a screen. That's it. The ePub spec exists. Validation tools exist. The format is fundamentally an open standard. HTML and CSS in a zip file with some metadata. This should be a solved problem. The reason it isn't solved is architectural. A closed, unmaintained rendering engine sits between an open standard and your eyeballs, and nobody outside Adobe can fix it. The good news, and this is genuinely good news, is that Kobo is apparently rewriting their e-reader software from scratch. A beta is available in the EU. No more RMSDK dependency. And for people who want the problem solved at the hardware level, the Pine Note exists. A Pine home device where you own the whole stack, software included. More expensive, less polished, but the architecture is right. The comedy here is deadpan and familiar to anyone who's ever validated their code against a spec, only to discover the spec doesn't matter because the implementation is proprietary and broken. Your ePub is fine. The closed system standing between your file and the screen is the problem. It was always the problem. 2 stories in and we're already seeing the pattern. So let's talk about Apple actually doing something interesting with on-device AI. In the 1990 licks, Microsoft shipped ODBC and changed how every Windows developer thought about databases. The abstraction was simple. Here's a protocol. Any database can conform to it. Your application code doesn't change when you swap what's underneath. Oracle, PostgreSQL, SQL Server. Didn't matter. The protocol was the product. The database became a commodity. Microsoft didn't need to build the best database. They needed to own the layer above it. Apple just did the same thing to large language models. The Foundation Models Framework, shipping in OS 27 betas, defines a language model session protocol. On-device model, Claude whatever comes next. Your Swift code calls respond to and doesn't care what's answering. Anthropic built a package that conforms Claude to this protocol. Same streaming interface, same tool calling, same guided generation. You instantiate a Claude language model instead of the local one, and everything else stays identical. Now let me argue the other side for a moment. You could say this is Apple inserting themselves as a toll booth, another platform abstraction that makes you dependent on their framework, their release cycle, their protocol design. Every time a platform vendor offers to simplify your life, they're also offering to own your integration point. But here's where that argument falls apart. Look at the architecture. Requests from your app go directly to the Claude API. Apple is not in the request path. They don't see prompts. They don't see responses. There's no proxy, no middleman, no data siphoning. The package is open source on GitHub. You can read every line of the conformance layer. And critically, your app decides which model to use per session. That's not a toll booth. That's a socket. What Apple actually built is a commoditization layer that makes LLM providers interchangeable at the API level. One of the Hacker News commenters nailed it. Apple is a hardware company. They want the best machine for running AI. They don't need to win the model race. They need the model race to make their hardware more valuable. The engineering deserves real admiration. Each Claude model carries its own capability declarations. What sampling parameters it accepts, whether it supports adaptive thinking, image input, structured output. The package uses these to decide which request fields to send, because sending a field a model rejects is a hard error. That's thoughtful protocol design. That's the kind of type-level safety that prevents an entire category of runtime failures. The practical question from the comments: how do you shift this to real users who won't paste in API keys? Is valid and unanswered, but the architecture supports multiple auth modes, and the pattern is clear. In production, your backend holds the key and proxies through your own service. What matters is the precedent. A major platform vendor just told every developer, treat language models as interchangeable infrastructure, conform to a protocol, swap providers without rewriting your app. That's commoditization. And commoditization is how open systems win. When the model is a socket, the best model wins on merit. When it's a walled garden, the default wins on friction. Apple, perhaps accidentally, just made the case for an open market in intelligence. Moving on. There's a concept in ecology called aposematism. It's when a species evolves bright, conspicuous coloring to advertise that it's dangerous. Poison dart frogs, coral snakes, monarch butterflies. The signal says, I am not to be messed with. But here's the thing about aposematism. It only works if you're actually toxic. When a harmless species mimics the pattern without the poison, biologists call it imitation mimicry. It's a bluff. And bluffs work great until a predator calls one. For about 40 years, the technology industry had the opposite of aposematism. Call it cryptocompetence. The coloring was deliberately dull. Khakis, bad haircuts. An almost aggressive disinterest in being perceived. And the signal worked. The public looked at these people and thought, they're clearly not optimizing for my attention. So they must be optimizing for the work. Wozniak giving away stock and going back to teach 5th grade. That's the most powerful trust signal possible. Someone who could demand your attention and actively declines it. The author of this piece frames what happened next as a liquidation event. And that's exactly right. Trust is an illiquid asset. It compounds slowly. It's hard to measure. And it feels like it's just sitting there doing nothing. Attention is liquid. It moves fast. It's measurable. it converts to funding rounds, and cable news appearances, and Twitter followers. So a generation of tech leaders looked at this enormous trust balance sheet and thought, we can convert this. And they could. For a while, the exchange rate looked incredible. But liquidating trust works like liquidating a thinly traded stock. The price holds until you actually try to sell in volume, and then it collapses. Every founder filming a mafia cosplay video, every CEO posting thirst traps about their management philosophy, every CTO building a personal brand louder than their product. Each one is a sell order on that trust balance. The comments on this piece are revealing. Multiple people push back and say nerds are always jerks. Which, sure, but that misses the point entirely. The jerkiness was tolerable precisely because it was aimed inward at the work. Cruel about kerning, obsessive about latency. The new version points the energy outward at the audience, and that changes the entire relationship. The good news. And this is where the builders come in. Is that trust still compounds the old way. Ship something useful, publish your source, let the work be louder than your LinkedIn presence. The poison dart frog strategy of look how dangerous and important I am has a shelf life. The Wozniak strategy of quietly being undeniable does not. 4 stories, and we're still finding reasons to be excited. This next one might be the most delightfully stubborn of the bunch. Emacs shipped its first version in 1976. 50 years of continuous development, and the article we're looking at today is someone discovering in 2024 that you can hover over a word and get a dictionary definition. Built in, no package. It's just been sitting there. This is a genuinely fascinating engineering problem, and it has nothing to do with missing features. Emacs has too many features. The surface area is so vast that a 20-year veteran can stumble across dictionary toinka mode and feel like they found a room in their house they'd never opened. The author's rule of thumb is telling. If you don't already know about undo in region, you've got lower hanging fruit to pick first. That's a feature for undoing changes inside a text selection. It's been there for decades. Most users have never heard of it. Pull this thread and you hit something architectural. Emacs is essentially a Lisp runtime that happens to edit text. Every feature is a function. Every function is discoverable through the same mechanism. Amino axis, type a name, hit enter. The system is radically transparent. You can inspect, modify, or replace any behavior while it's running. The source code for every built-in feature ships with the editor. This is what an open system actually looks like when you follow the principle to its logical conclusion. But transparency is not the same as discoverability. The find file with wildcards demo in this article is a perfect example. C times XEICI is probably the single most used Emacs key binding. Every user runs it hundreds of times a day, and most of them have no idea you can pass it a glob pattern like *foo* *regnon time and open 12 files at once. The capability has been 2 keystrokes away for years. The knowledge gap isn't access. It's attention. One commenter has been using Emacs since 1994 and says they still don't understand Dyard. 32 years. That's not a user failure. That's what happens when a system grows organically for half a century with no marketing department and no onboarding team. Just contributors quietly adding capabilities and trusting that someone eventually will find them. The tools exist. The source is available. The documentation is built into the runtime itself. What Karthik is doing with these articles. just pointing at rooms people haven't opened yet. Turns out to be exactly what an open system needs most. Not more features, better maps. Moving on. I've spent enough time building access control systems to know a fundamental truth about them. Every gate you build, you also build the blueprint for picking it. The more sophisticated the lock, the more interesting it becomes to people who pick locks for fun. Anthropic built Mythos, decided it was too dangerous to release. Then released a guardrailed version called Fable, which by most accounts is genuinely a generational leap in capability. Then someone jailbroke it. Then the U.S. government issued an export control directive shutting down access for all foreign nationals, including Anthropic's own employees. The company says the jailbreak was narrow and the vulnerabilities it exposed were already known. The government says Anthropic is being cavalier with national security. The facts are disputed. The pattern is not. Run this forward. Every frontier model from here on will be more capable than the last at finding and exploiting vulnerabilities. Every release will face the same tension. Keep it closed and maintain control, or open it up and lose the ability to dictate who uses it and how. Anthropic chose a middle path, a controlled release with safety guardrails, and the middle path collapsed in weeks. The article frames this as a question about whether Anthropic should have released Fable at all. That framing accepts a premise worth examining, that a single company should be the arbiter of who gets access to powerful reasoning capabilities. The U.S. government apparently agrees with that premise. They just want to be the one holding the keys instead. What neither party is discussing is the structural problem. A closed model with guardrails is a lock. Locks get picked. The jailbreak that triggered this crisis was reportedly flagged by Amazon, simultaneously an investor in Anthropic and a provider of its inference infrastructure. The incentive geometry here is worth noting. With precision, the company that helps run your models is also the company that reported the security failure to the government. The alternative architecture exists. Open weight models, distributed inference, safety research conducted in the open where 1,000 security researchers can probe and harden. Instead of one company playing whack-a-mole with jailbreaks behind closed doors. The argument against releasing powerful models openly is that bad actors will misuse them. The argument for it is that closed release didn't prevent misuse either. It just ensured that when the failure came, one company and one government were the only ones at the table deciding what happens next. Better engineering beats better locks. It always has. Moving on. One commenter on this story cut straight to it. A large number of Airbnb hosts were using the Business Manager visa as a residency hack. Buy a guest house in Osaka, rent it out. Maintain your visa status. The scheme was real. The fraud was documented. And Japan's government responded the way governments always respond to system abuse. By raising the walls so high that the legitimate users can't climb them either. This pattern has a name in computing. It's called the DRM problem. In 2005, Sony BMG shipped rootkit copy protection on millions of music CDs. The pirates ripped and shared the albums within hours. The paying customers got malware installed on their computers. The people who played by the rules suffered. The people who didn't were unaffected. Sony's response to a distribution problem made the product worse for every honest buyer while doing nothing to stop the dishonest ones. Japan just did the same thing to 36,000 small business owners. The numbers deserve a straight reading. the capital requirement jumped from 5 million yen to 30 million. A six-fold increase. Only 4% of current visa holders meet that threshold. Applications dropped 96% in the months after the announcement, from 1,700 per month to 70 less. There are 5,000 Indo-Nepalese curry restaurants in Japan, more than the number of McDonald's in the country. These are family operations where the owner cooks, cleans, serves, and manages the books, because that is what running a small restaurant means. The new rules require a dedicated full-time Japanese employee and proof that the owner is engaged exclusively in managerial duties. That requirement describes a corporation. It does not describe a curry shop. 67,000 people signed a petition to review the capital threshold. Japanese customers defending the restaurants in their neighborhoods. The broad problem was real, but the solution targets the wrong population with mathematical precision. 96% of legitimate applicants eliminated to catch a minority of bad actors. When your security measure has a 96% false positive rate, you haven't solved the problem. You've created a new one. The families who built these businesses, who put down roots, who became part of the fabric of Japanese neighborhoods. They deserved better engineering than this. Moving on. Humanity spent 50 years trying to replace committees with software, and now we're building committees out of software. Openrouter Fusion API takes your prompt, fans it out to a panel of frontier models running in parallel, each with web search enabled, then routes all their responses to a judge model that synthesizes everything into a structured analysis. Consensus, contradictions, blind spots, the whole deliberation. You get back one answer that represents the considered opinion of several AI systems arguing with each other on your behalf. The engineering is genuinely clever. Ensemble methods have deep roots in machine learning. Random forests. Boosting mixture of experts. The insight that multiple weaker signals combine into a stronger one is decades old. What's new is doing it at the reasoning layer, across competing frontier models, with live web access, behind a single API call. That's infrastructure work worth respecting. And the architecture matters here. Openrouter is a routing layer. They don't own the models. They built a protocol that lets you compose capabilities from multiple providers into something none of them offer individually. One commenter immediately saw it. Writing specs before coding starts and throwing maximum LLM horsepower at gap analysis, where the token count is small enough that the cost multiplication barely registers. Another asked whether fusion techniques could improve local AI by streaming from multiple machines. People are already thinking about how to take this pattern and run it somewhere else. Now the numbers. Someone ran an eval 7 times slower, 4 times the cost. And honestly, for the use cases where this matters, research synthesis, expert critique, anything where being wrong costs more than being slow. That's a reasonable trade. You're not using this for autocomplete. You're using this when you need to be right. The real win is that this deliberation pattern is now an API endpoint, not a proprietary internal process at a frontier lab, not a research paper you'd need a team to implement, a URL. Anyone building anything can call it. The technique is in the open, the implementation is accessible. And the first thing people did was start figuring out how to make it cheaper and more local. That's the bootstrap doing what it does. Sharp left turn here, from making AI thing harder to making the internet's plumbing more humane. Agar pies, curl is setting boundaries, and it's kind of beautiful. Let me make the strongest case against this. Daniel Stunberg maintains one of the most critical pieces of infrastructure on the internet. Curl is everywhere. Every phone, every server, every connected device. Closing the vulnerability intake for an entire month is, on paper, reckless. A 0-day discovered July 3rd just sits in the wild for 4 weeks. Responsible disclosure depends on someone being on the other end of the line. Shutting that off feels like a firefighter unplugging the alarm and going to the beach. Now, let me tell you why that argument collapses under its own weight. Follow the logic to its conclusion. If curl's security posture genuinely depends on one person never taking a vacation, then we don't have a security model. We have a single point of failure dressed up as a process. And the people most loudly concerned about this month-long pause should be asking themselves a harder question. Why is the entire vulnerability pipeline for software running on billions of devices funneled through a maintainer working, essentially, for free? The engineering here is what deserves attention. Look at what Daniel actually built with this announcement. Paid support contracts remain active through July. The GitHub trackers stay open. Bug fixes and new code still happen. What's paused is specifically the high-pressure, adversarial intake of security reports, many of which, as he's noted, have been an overwhelming deluge for 4 months straight. He separated the load-bearing operational work from the part that was burning people out. And he did it cleanly. One commenter nailed something the headline missed. This is also a forcing function for enterprise support contracts. If your business depends on curl and you need guaranteed security response times, there's a mechanism for that. It's called paying for it. The architecture of this decision quietly makes uncomic case that maintainers have been unable to make politely for decades. The beautiful part is the invitation. He's asking other open source projects to join, a collective summer of bliss. Maintainers coordinating not on code, but on rest, on the radical assertion that the people who build the commons deserve to exist as humans within it. The bad guys won't rest, Daniel writes. Probably not, but we will. That's craft. That's someone who's been doing this for 28 years and finally has the standing and the clarity to say the infrastructure will hold. It was built well enough to survive a month of peace. From rest to capture, someone built a tool that lets you bottle an entire website into a single binary. And yes, it's exactly as cool as it sounds. Save as, 2 words that have been lying to you for 30 years. Every browser ships with this promise. Save this page. It's yours now, and every saved page eventually decays into a blank screen, a frozen spinner, or a quiet fetch to an analytics endpoint that stopped responding in 2019. The page was never yours. It was a rental agreement disguised as a file. Code asks a question nobody in browser development seems willing to ask out loud. Why does saving a web page require trussing the web page? The tool is written in Go. It drives a real headless Chrome instance, lets the page fully render. JavaScript, lazy loaded images, the whole performance. Then snapshots the DOM exactly as a human would have seen it and strips every script tag out of the result. What you get is HTML, CSS, images, and fonts, static files. No network calls, no tracking, no code execution at all. The detail that caught me is the idempotency. Same page reached over HTTP or HTTPS with or without a trailing slash. Gets fetched exactly once. That's not a feature you add for fun. That's a feature you add because you've personally been burned by a crawler that downloaded the same essay 14 times under 14, slightly different URLs. This is a tool built by someone who actually uses it. And then there's the pack command. You can collapse an entire mirrored site into a single executable binary. The binary is the server. Double-click it, and it serves itself. No runtime, no dependencies, no Docker, nothing. Paul Graham's entire essay collection has a 64-bit executable you can email to someone. The architecture here is the editorial. Every technical decision. Strip the scripts. Localize the assets. Pack to a single binary. Points in one direction. The content belongs to the reader, not the server. Open tool, open format, no lock-in. You clone it, you own it. The way saving a page was supposed to work all along. We talked earlier about tools that give power back. Here's one that gives math back. Story 10. There is such that. In 1967, Ken Knowlton at Bell Labs created Bellflix, a programming language whose only purpose was to make pictures. Not business logic, not calculations. Pictures. Most of his colleagues thought it was a toy. Knowlton understood something they didn't. A language shapes what you can think, and a language built for visual expression lets you think visually. FractoKitty's clock language operates on exactly this principle. It's a compositional system where the primitives are vectors of time, hours, minutes, seconds, and the operations are the things you'd actually do with vectors. Dot products, magnitudes, rotations. Ravens carry hours. Crows carry minutes. A magpie handles seconds. The notation borrows from set theory, the aesthetics borrow from nature, and the whole thing compiles to a p5.js sketch running in your browser. Let's break down what's actually happening architecturally. The editor is a node graph called the loom. You drag typed nodes, vectors, scalars, glyphs, habitat, and connect them with arrows. A compiler called the Weave watches every change and recompiles your composition into a live preview. The exported artifact is a single HTML file with p5.jmes inline. No CDN calls, no runtime, no server. Open it offline, drop it on a personal site. Done. The comments struggled with the mathematical notation, and that's fair. But the craft underneath deserves attention. One source of truth for time. Procedural rendering from primitives with randomness. Local storage for undue history. A wordless interface using hand-drawn sigils instead of labels. This is what creative toolmaking looks like when you build for expression instead of extraction. The loom weaves, the clock reads, the whole thing fits in a file you own. This has been your daily tech feed for Hacker News for June 15th, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voiced by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now, go build something that belongs to the people who use it. We'll see you back here tomorrow.